Now we're going to be solving related rates problems. Related rates problems are interesting. You're going to be using derivatives, but you're going to be needing to use implicit differentiation because you're going to have problems where when you do the diagram, they end up being non-function. A cube is not a function. Remember, a function, if you do a vertical line test, a function is where if you put a vertical line through a function, it only touches once. Well, with a cube or a circle or many shapes, when you put a vertical line through it, it's going to hit it at least twice. So, but here is the process. When you read a related rates problem, there's 3 things that you must do. Well, 3 to 4 things that you must do right away. And I don't know that this part matters so much in order, but one of the things you need to do is draw the diagram of the situation. Second, another thing you need to do is you have to figure out what information do you know or that has been given. And to go with that would be what formulas are associated with the information that's known or given or the diagram. And then finally, you need to state what it is that you need to find. All right, I'm going to actually go ahead and erase that so I can give myself some room. And I went ahead and drew the diagram. So a hypothetical cube grows so that the length of its sides are increasing at a rate of 3 meters per minute. How fast is the volume of the cube increasing when the sides are 8 meters? So I drew the cube, and then I drew this kind of cube that has grown, and I went ahead and state the sides are increasing. The up arrow means increasing at 3 meters, and I put seconds, and it should be minutes. Okay, so that pretty much, I indicated on the diagram that it's a cube, so notice I marked the sides of the face of the square, the front face, that all the sides are the same. That would indicate, and we could go ahead and do that. That would indicate that this is a cube that we're talking about. And I marked, I could do a third side. I marked that all 3 of the sides, the length, the width, the height, are all the same measurement by the same, indicating that it's the same letter. Next thing I'm going to write is what is it that we're finding? How fast is the volume of the cube increasing? So since it's a rate, we need to find dV dt when the sides are 8 meters. So what is it that we know? We know that the length of its sides, so the sides are increasing at a rate of 3 meters per minute. And we're talking about the volume. Well, the volume of a cube is just, remember, the volume of a cube is length times width times height. But in this case, for a cube, the sides are the same. So you actually can just rewrite it as sides cubed. This problem is pretty simplistic because we know all the information that we can just go ahead and get started and fill in the parts. So since we're finding dV of dt, so when we take the derivative of the volume, we take the derivative on the right side, which would be 3s squared. But remember, this is not a function, so we do implicit. So then we tack on, since this is s, ds dt. Okay, well, we know what ds dt is, so we can fill that in for here. And we're finding the volume when s is equal to 8 meters. So that's what we're going to do. We're just going to now fill in all the information. So the sides are 8 meters squared, and the ds dt is 3 meters per minute. And then we're just going to go ahead and do the math. Well, 8 squared is 64, and then meter squared is meter squared. And we've got a 3 times, and over here we have a 3 times meters per minute. I always want to put seconds. Well, 3 times 3 is 9, so I'm just going to 64 times 9. Let's see, we have 6. Carry that 3, 576. So the volume is increasing at a rate of 576 meters cubed, because here you have meter squared times meter is meters cubed per minute. When at the exact point when the rate of the sides increasing are 8 meters per minute. That's it. So that's a simplistic version. They get a little bit harder, but that'll get us started on solving related rates problem. Oops, sorry about that.